Viewers, this is the video lecture for the topic Constraint Satisfaction Problem for the first unit of Artificial Intelligence and Machine Learning. The goal is to discover some problem state that satisfies a given set of constraints. Basic workflow of constraint satisfaction problem. First of all, we need to analyze the problem perfectly. We need to derive the constraints given in the problem. Then we need to derive a solution from a given constraint. Find whether we have reached the goal state. If we have not reached the goal state, we need to make a guess, and that guess has to be added as the new constraint. After adding new constraint, again we go for the evaluation of solution. Now we need to solve the problem by using this added new constraint. Again we have to check whether we have reached the goal state. If yes, solution found. So these are the different problems called as script arithmetic problems. These problems are coming under the constraint satisfaction problems. Let us see one example. Send plus more equal to money. The concept is assign decimal digit to each of the letters in such a way that the answer to the problem is correct to the same letter occurs more than once. It must be assigned the same digit each time. No two different letters may be assigned the same digit. Consider the script arithmetic problem. There are some constraints to solve this problem. No two digit can be assigned to the same letter. Only single digit number can be assigned to a letter. No two letters can be assigned same digit. Assumption can be made at various levels such that they do not contradict each other. The problem can be decomposed into secured constraints. A constraint satisfaction approach may be used. Any of the search techniques can be used and backtracking can be performed. Rule of arithmetic may be used. Initial state of the above problem is we have to find out the digit for all the letters D, E, Y, N, R, O, S, M, C1 and C2. C1, C2, C3 stands for the carry variables available needed for the sum of two letters send plus more equal to money. Goal state, the digits to the letter must be assigned in such a manner so that the sum should be satisfied. The solution process proceeds in cycles. At each cycle, two important things are done. Constraints are propagated by using rules that corresponds to the properties of arithmetic. A value is guessed for some letter whose value is not determined. So this is the tree showing how the values are propagated. How can we assume the values, and we will try whether all the conditions are satisfied. So initially we can put from the left side onwards we will try to assume values for the letter m equal to 1. Since two single digit numbers plus a carry cannot be more than 90. S equal to S can be assigned as 8 or 9 since S plus M plus C3 should be greater than 9. So and M equal to 1, S plus 1 plus C3 should be greater than 9. So S plus C3 should be greater than 8 and C3 is at most 1. O equal to 0. Since S plus M plus C3 must be at least 10 to generate a carry, and it can be at most 11, but M is already 1, so O must be 0. N equal to E or E plus 1 depending on the value of C2. But N cannot have the same value as E, so N equal to E plus 1 and C2 is 1. In order for C2 to be 1, the sum of N plus R plus C1 must be greater than 8. N plus R cannot be greater than 18 even with a carry in, so E cannot be 9. Assume that no more constraints can be generated. To progress at this point, guessing happens. If E is assigned to the value 2, now the next cycle begins. N equal to 3 since N equal to E plus 1. R equal to 8 or 9. But since N is already 3, the sum of these non-negative numbers cannot be less than 3. Thus R plus 3 plus 0 or 1 is equal to 12 and R equal to 8 or 9. 2 plus D equal to Y or 2 plus D equal to 10 plus Y from the sum in the rightmost column. Assuming no more constraint generation, this guess is required. So in this way, we will assume the values without producing conflict with other letters. And also the important thing is to assign the value 0 or 1 for C1, C2, C3, and all the letters should satisfy the conditions of constraint satisfaction. And finally we need to get the values for all the letters. So that is the example for constraint satisfaction problem. Thank you.